What's going on, everybody? It's Joe. Welcome back for another episode of Triangle Diagnostics. What we got right here, guys, 01 GMC Sonoma. The customer's complaining on this one just to check engine light. So for me, I think we're just going to go straight to the scan tool. Let's see what trouble codes we have, and then we'll figure out how we want to attack this thing. So let's do it. Alright guys, we're going to start from the home screen on this one. I've got the key on, so we're just going to go ahead and identify the vehicle. Working on a GMC, and this is a 2001 model year. We'll try the automatic ID, see what it does. Honestly, I don't believe it's going to work on this car, guys. Most of the time, these older vehicles. Whoa, man, look at that. Man, I'm giving you guys all sorts of wrong information today. So yeah, there we go. 2001 Sonoma. This is a rear-wheel drive vehicle, and we have the 2.2 four-cylinder engine equipped. We're just going to hit OK on that. This is the automatic transmission, guys. So we're going to go straight to engine here. I already have the DA4 unit connected. We're going to go to codes, display codes, and let's see what we have. Alright, so it looks like we have a P0122 throttle position or accelerator pedal position, sensor 1 circuit short low. We also have a P0410 secondary air injection system fault code. One thing I know kind of off the top of my head on this, guys, this is not a drive-by-wire vehicle. It just has a throttle cable. But this is potentially looking like two completely separate issues. Not sure going into it, but I think for the sake of simplicity, let's take a look and attack this P0122, the throttle position code, first. And maybe we'll do the secondary air system fault in a different video, depending on if it's related or not. So kind of what I want to do with this code here is I just want to get some information about it. Something I know right off the top of my head is a 3-wire sensor. It's a potentiometer. So there's some pretty universal testing methods we can use to troubleshoot this, but really I just want some information from the troubleshooter just kind of going into this. So I'm going to go to the troubleshooter menu inside of the engine sub-menu, and I'm looking for code tips. And remember, guys, our fault code was P0122. There's our guy there. So just looking for some basic info on how this code sets here, guys. It's all I'm really using this for. So it gives us a brief little circuit description here. Looks like we have a 5-volt reference, a low reference, and a signal. So this is basically just a 3-wire 5-volt potentiometer. Pretty simple design. Just kind of scrolling down through this again. So kind of reading off this, rotation of the TP sensor rotor from the closed throttle position to the wide open throttle position provides the PCM with a signal voltage from less than 1 volt to greater than 4 volts to the TP throttle plate sensor signal circuit. Typically what I see on these guys, just for some quick info, generally a closed throttle voltage reading on some of these is going to be around half a volt, and generally wide open throttle is going to be around 4.5 volts. So let's just keep that in mind going into this. As far as code set conditions here, we have throttle position sensor signal voltage is less than 0.15 volts. So some good info here, guys. I think we know, kind of how we want to attack this. And I think the best thing for us to do at this point is let's go to scan data and let's see what we have. Alright guys, so I've got some scan data pulled up here. I'm just reading at a relative throttle position system sensor percentage value on the right, and then we have a throttle position sensor voltage value on the left here. Really, kind of what I'm looking at is I'm just kind of getting a gauge of what our current measurements are. And you can see this TPS voltage number is right around 0.39 volts. That's not too far out of the norm here, guys. You can see the throttle plate's currently closed. The truck is not currently running. So I think our next step is let's get the truck running, or at least go over to the truck, and let's do some manual throttle sweeps while we watch this TPS voltage number. So that's coming up next. Alrighty guys, so I've got you guys focused in on the scan tool, and hopefully you guys can see it alright. I'm not going to run the vehicle for this test. What I'm going to do, this being a drive-by-wire system, is all I'm going to actually do with this is I'm just going to manually move this throttle valve back and forth, and we're going to watch the scan tool, and we're going to see what our throttle position sensor signal voltage does. So I'm just going to get you guys propped up right here so you guys can view that, and you can see we had those sweeps on the screen where we did this test. So all I'm going to do, guys, is I'm just going to very slowly move this throttle from the closed position to the open, and we're going to watch this signal voltage here, and we're going to look for any dropouts or glitches in this signal. And I'm just smoothly opening this. all the way to wide open throttle. And I just let off a little early there, guys. I'm going to do it again. And what we're looking for here, guys, is we want to see a nice, smooth, upwards ramp with no dropouts or glitches all the way to the top of this throttle. I just hit the max position there. I'm just going to go ahead and slowly move this back. I'm slowly closing the throttle here, guys. The throttle is now closed. I'm going to do that one more time a little faster. That was all I was doing, guys, just moving that throttle plate. I'm actually going to pause this and just kind of move back in this buffer just because I didn't have a clear view on this while we were doing this test. But it looks like we potentially saw an issue here. Yeah, we definitely did, guys. It looks like the first time we did this test here, we had this straight dropout here. You can see this around frame 760. Let me get you guys zoomed in on that. Yeah, so if we look at this frame 760, guys, you can see where we clearly lost the signal voltage. You know, at this point in time, I was just continuously opening that throttle valve real slow. But I mean, we could clearly see that we dropped down to 0 volts here. So right off the bat, you know, we can definitely duplicate this issue here, guys, without a doubt. So our next steps in attacking this TPS, which it's definitely leaning towards being a faulty TPS based off of the fact that this signal is good at all other points, is we just need to do some quick checks at the sensor itself. You know, let's verify our 5-volt feed to this sensor as well as the sensor ground, and then we'll do some signal circuit integrity tests before potentially calling this as a bad sensor. So let me get you guys set up. Alright guys, we're staring at the front of the truck here, and I just want you guys to have some sort of idea of where this sensor lives. If we look on top of this, we can see this unit right here. This is the throttle body. If we look directly to where I'm pointing, I'm going to get you guys zoomed in on it. That little disc looking doodad there with the 2 screws at, that's our throttle position sensor, guys, and that's what we need to be testing. As far as its location and its ease of testing, the connector for it is kind of tucked away behind this air box right there. It's going to be pretty hard to test that, you know, in that location unless we remove this box here. I'm not sure how big of a deal that's going to be. You know, we could also test it. You know, we could put a piercing tool or something like that in this wire, but you know, I don't really want to do that, guys. I don't like putting holes in wire if I don't have to. So I think the next step we need to do to get to this throttle position sensor is let's quickly get this air box out of the way, and then we can access the connector directly, and then we'll perform some testing there. So to remove this air box, guys, it's pretty simple. You know, I'll give you a brief explanation, then I'll show you how to do it on camera. We have a hose clamp right here, just holding this hose onto this air box unit. We have one 10mm fastener here that I'm pointing to. We have a smaller hose that comes into the back of this unit. Let me see if I can get you guys a good angle on that. Comes right back here. I'm touching it with my hand. It's kind of underneath this throttle plate right here. It just hooks into the back of this air box, guys. No big deal there. And then if we look directly at the throttle plate, we also have this last hose clamp. So I'm going to get you guys set up, and I'm very quickly going to whiz this unit off of here so we can access this throttle position sensor. Alrighty guys, so I'm just going to go ahead and start whizzing this stuff off. I'm going to try and do this pretty much as quickly as I possibly can. Really, I'm just trying to kind of get this thing figured out and done. You know, so hopefully I can potentially get parts for this thing and maybe show you the fix if it's, you know, if it does in fact just end up being the throttle position sensor. But one thing I'll talk about, guys, while I do this is the sweep test that we originally executed, where we slowly open that throttle plate up. You know, that's an excellent test at catching glitches in a throttle position sensor signal. And oftentimes, guys, when you're doing that and you see those glitches, it's very likely going to be the throttle position sensor. You know, there's a very small potential that it could be something like a wiring problem, guys, but I mean, honestly, it's pretty doubtful. So we got that one bolt out. I just got this hose disconnected back here, the one that I showed you guys on camera. Here's the airbox unit. So we got that all out of there. And then what we're going to be attacking, again, that right there, guys, throttle position sensor. So yeah, let's get some quick views of it. And sorry about the shakiness here, guys. So as we can see, this is a 3-wire potentiometer here, guys. We have 3 wires coming off of it. I have what appears to be a gray, maybe. I also have a blue and what appears to be a black. Knowing GMs of this vintage, the gray wire is going to be the 5-volt reference. So there's some good information for you guys. But all we're going to do at this point, guys, is I'm going to get the Vantage. We're going to start testing these circuits independently, verify we have good circuits, and yeah, we'll see what's wrong with this strut. Alrighty, guys, so for some simplicity's sake, I've got you guys focused in on the digital multimeter. We're using the Vantage here. So I've got my black lead going to battery negative. I'm just going to touch my red lead onto battery positive to ensure we have a good ground for our meter. We're reading 12.53 volts, so that's looking good. So we're going to start attacking this throttle position sensor at this point, and you guys are going to be able to see me testing the sensor too well from your location, but you will be able to see the meter. And I'm going to definitely walk you guys through, what wire I'm hooked into and all that good stuff. So just turning the key on here, guys. I'm just taking a look at this sensor here. And I think the obvious first choice that I want to look at is I want to confirm that we have a good reference feed to this sensor here. So I'm just taking a look at this connector, and I'm just back probing this gray wire here, guys, trying to go in nice and straight. I feel like I'm in there pretty good, guys. I'm just going to hook my meter up. And as we can see on the Vantage here, we have a number of 5.06 volts. So nothing wrong with that reference, but you got to remember about how this thing was failing. We were dropping this signal out at the lower portion of its range. So what I'm going to do is I'm just going to slowly move this throttle position sensor through its range, and I just want to keep an eye on this reference voltage, and you guys should be able to see that pretty good. So I'm just slowly opening this throttle here, guys, and we're just watching this reference number to make sure it stays consistent, and it does. Moving back to the closed position here, and all the way to closed. And yeah, that looks good. So not suspecting a reference circuit issue here, guys, whatsoever. My next step here is going to be, I want to look at this sensor ground. That's going to be the black wire on this throttle position sensor on this vehicle. So I'm just getting my T-pin installed there. And honestly, guys, a lot of guys would just put a throttle position sensor in this car. And in most cases they would probably fix it. But the big thing that I want to stress to you, especially on this channel, is we want to be 100% about the tests that we're doing. Really, I just want to stress being 100% on any call that you make. So, we're going to do our diligence, and we're going to test all 3 of these circuits, and we're going to make sure that this is in fact a throttle position sensor. I'd hate to be wrong about a call like that. So, but anyways, guys, just continuing on, we're now on the sensor ground, and we're just taking a look at our Vantage. We see 0.04 millivolts. So absolutely nothing wrong with that. I'm just going to go ahead and execute that sweep test very quickly. Moving the throttle plate to the open position, making sure that we don't have high voltage on this ground. What we're looking for here, guys, when we're testing the ground, is we're looking for high voltage. I'm just going to sweep that one more time. This is looking good on this. Yeah, no issues there. So our last one that we really need to be concerned about here, guys, is the signal wire. I'm not sure what design signal circuit this is. I don't know if it is a pull up or a pull down signal circuit. I kind of want to say that it's a pull up, but I could be absolutely wrong. So obviously the key of the vehicle is on here, guys. We're just going to get an initial measurement of this throttle position sensor. We should be around that 0.5 voltage number that we had, and you can see we are. So I'm just going to re-execute this test on the signal wire, guys. I'm just going to slowly open this throttle plate, and we're going to watch this voltage. And you can see right there, we dropped down to 0.06 volts. I'm going to back it off a little, back up to 0.6, open it back up, and there we are, back at that 0.06 number. So yeah, this is definitely a bad throttle position sensor, guys, no doubt. I'm just kind of continuing through the sweep here, and we can see that our maximum number climbs up to about 4.5 volts. What I want to do for you guys to better emphasize these dropouts is let's go to our graphing meter. And let's actually graph this signal over time. And I think that's really going to emphasize what this glitch looks like to you guys. you know, doing it on the digital multimeter isn't really the clearest way to go about it. So I'm just going to widen this scale up a little bit. We'll go to a 10-second scale, should be sufficient. So I'm just going to slowly open this, guys, and we're going to watch the Vantage. And you can see it right there. So back to our start point. You can see our start point here is this 0.45 number. Hopefully you guys can still see that. Let me make sure you guys can. Yeah, let me get you guys zoomed in a little, actually. So I'm just getting you guys focused on the Vantage so you can see this real well. So all I'm going to do, guys, just like we've been doing this entire time, is I'm just going to move this throttle plate while you guys watch this. Our start point is 0.45. This signal should climb to 4.5 volts evenly with no dropouts or glitches, and you can see right at the bottom of this. This is dropping right there to around 0 volts. I'll see if I can get it held in that position. Just slowly opening it. We see a little glitch there, and there we see it. So I'm just kind of holding it around this bad place on this throttle position sensor, guys, where I'm trying to let back off of this. It's a pretty small spot that's bad on this, guys. Let me see if I can get it back in that spot. It's kind of just right off, right into it just a little bit is where that spot is, guys. It's a little tough to get it. There it is. You can see where we just went back down, and bam, there it is, guys. We can see a little bit of fluctuation in that line there, guys. It kind of implies an open circuit. So really this would be a bad portion of this potentiometer. There's a little lever inside of it that sweeps along a variable resistance sort of, man, I'm not even sure what you would call it, but I'm just going to let off a little bit and we'll see this voltage number jump back up, as you can see there. So without a doubt, guys, this is the bad throttle position sensor. I'm just going to do it quickly now. A few quick snaps. And you can see if you move it quick enough, but I mean we can still even see that that glitch is there. You see that bouncing across the screen. If we were to put peak detect on, I'm sure that we would capture this glitch a lot better every time. So we're on peak detect now here, guys. And we saw one there. Yeah, so just kind of right off idle is where this throttle position sensor is bad, guys. You know, no doubt about it. I'll show you guys one more time. And there it is. That's a pretty picture. So yeah, guys, I mean, we're pretty much done with this. Bad throttle position sensor, 2001 GMC Sonoma with the 2.2. What I'm going to do is I'm going to attempt to get a throttle position sensor, and we're going to do the install and then verify the repair. Alrighty, guys, so got a hold of our friends over at Advance, and they had one of these in stock, and it was a measly $30 or so. But this is it, guys. This is the throttle position sensor. Let me see if I can get you guys kind of focused in maybe on how this works exactly. I know the lighting is a little bit bad here. Let me see. See, that's kind of shining you guys out there. Maybe I can get you guys on the car a little bit just to talk about this thing a little bit. But if we look inside of this unit, there's basically a little place where a shaft coming off of the throttle plate hooks into, and that shaft is going to rotate, and it drives a little lever inside of this unit, and that lever sweeps across a variable resistor, and that's what's going to basically signal the engine computer as far as where this throttle plate really is, you know, living. So that's kind of all there is to it, guys. But what we're going to do is we're going to replace this, and then we're going to show the fix after this. Alrighty, guys, so I've got you guys zoomed into the meat and potatoes of the issue, as it were. What we're going to do here, guys, we're just going to remove this throttle position sensor. So our first step at this point is just get our lead out of the way. We're going to disconnect this electrical connector. You know, you just pull this tab off. It comes right out. You know, no big deal. Get this T-pin out of here. So this unit's held on here by 2 T20 screws. So I've just got a ratchet here, and I'm just going to get this thing broken loose and off of this thing real quick. You know, these fasteners are not very tight, guys. They also do not need to be reinstalled tight. So just pulling these screws out of here. Obviously, in order to replace this unit, guys, you would need to pull that air box out, you know, so you can get a ratchet in here and do this. But, you know, obviously we already did that during the testing process on this thing. But something you got to watch out for on some of these units, these throttle position sensors need to be adjusted to have a the proper voltage reading with a closed throttle. I don't believe that this design is one of them. I don't see any slots or anything like that for rotating the sensor when I was looking at the new one. So I don't believe that's what we're looking at here, guys. I think this is just a plug and play sort of unit. So that's good. That makes changing these out a real breeze. Nothing really else to think about. But something to definitely watch out for on other vehicles potentially is that you may need to perform a basic base closed throttle voltage calibration on these to make sure that they're sitting at the right spot. This one, as I said, I don't believe that is the case. The sensor does not appear slotted in any way, and you can't really rotate it off of the shaft. So we can see the shaft here it lives in, guys. The old sensor that we just pulled off, you can see that it's actually keyed to the shaft, so you can really only kind of put it on one way. So we're just getting that old sensor off of there. We're going to put this new sensor on. Just kind of moving that sensor around, making sure it finds its place and it snaps in, and it does. We're going to get these screws back wound in here. So, pretty basic job here, guys. I just figured I'd show you what the hey, just in case you were dealing with it on your own. Some folks aren't super mechanically inclined, so videos like this, it could potentially help them out on how to do this. Some of my other viewers, they're probably thinking get to the fix now already, but it's got to be replaced anyways, guys, so we might as well show it for the people that really do need to know how to do it. So we're just getting these screws back in here, guys, just getting wound down as far as I can. You got to remember, this is a really thin, flimsy plastic housing. These screws do not need to be super tight. You are literally pretty much just snugging this down. That's really all there is to it. Do not go hulking these on here. You will damage your new sensor, almost guaranteed. You also run the risk of potentially shearing off one of these tiny little screws in the throttle body, and then you're definitely up the creek without a paddle there if you do that. So again, you're just looking to snug these up, and I mean, really, that's it. That's all I'm doing. That's all I'm giving these guys. So just making sure this unit's nice and tight. Wham bam. Thank you, ma'am. That's all there is to it, guys. We'll get this electrical connector plugged back in. And what we're going to do at this point is I'm going to get you guys back on the Vantage, and we're going to confirm the repair on this. Something that we also didn't do before condemning this sensor, we really didn't have to, is let's determine what sort of signal circuit design we're dealing with, whether it's pull up or pull down, and then we can use that information in the future for dealing with this. So let me get you guys back on the Vantage. Alrighty, guys, so I've got you guys back on the Vantage here, and as I stated before, the first thing I really want to do here, I just want to determine what sort of signal circuit design this was. And as I said, I forgot to do this before, but it's something we really need to know for the future. So all I'm doing here is I'm just locating my signal wire, on this connector. That's going to be the blue wire, and I'm just front probing that now. And taking a look at the Vantage here, guys, we have this number of 0.02 volts. So this is definitely a pull-up signal. This sensor is sending this voltage to the engine computer. It is not the other way around. So, let's keep that in mind for the future. If you had any question about wiring integrity, what you could do really is you could take a test light, place it on battery positive, and you could touch this signal wire and you could watch for a response on the scan tool. So pretty simple, guys, but all I'm going to do at this point is I'm just going to re-T-pin our signal wire, which is the blue wire on this. Let's get hooked back into that. Alright, let me turn our key on. Got a little ahead of myself there. Wasn't trying to turn the key on quite that much. Looks like I do not have a good connection here, guys. I'm just trying to get back in here and make sure I'm all the way in this. There we go. So we're seeing a number 0.63 volts. So all I'm going to do at this point, guys, is I'm just going to move this throttle plate open, and what we should see is a clean signal with no dropouts or glitches. That's wide open throttle, coming back down to closed, doing it again, all the way to wide open throttle, coming back down to closed, and we'll do it one more time. You know, you really want to do this test slow, guys, especially if you're using scan data for this. The refresh rate of scan data will oftentimes not catch this, as well as your sampling rate of whatever meter you're using. Being that we're on a 10-second scale on this graphing multimeter, you know, we need to do it somewhat slow. I believe that the glitch capture specification for the graphing meter on this Vantage in the graphing meter mode is 3 milliseconds. So a 3 millisecond glitch will catch, but as you can see, guys, this is fixed. That initial low voltage glitch that we had at the beginning of this waveform is no longer present. This waveform is clean. I'm currently wide open throttle. Our voltage measurement is 4.43 volts open. I'm going to close this, and our closed voltage measurement is 0.61 volts. That is well within specifications for this, guy, so that's a fix. So pretty simple, pretty easy, and that's truly all there is to it when you're dealing with these 3-wire potentiometer faults. So yeah. I think one thing I want to do before we close this video is I want to show you how to do a pull-up circuit signal integrity test, and we're going to be doing that using the scan tool. So let me get you guys focused on that. Alright guys, so we're focused back on the scan tool, and kind of what I want to talk about real quick is, you know, this being a pull-up design circuit, this sensor is actually sending voltage to the engine computer. So this, we're just in the scan tool data menu currently, guys. Now we see that we have this throttle position voltage number of 0.57 volts. Really what this means, guys, is this throttle position sensor is sending 0.57 volts to this engine computer. What we need to do at this point, let's say that we had a vehicle that came in and we had a 0 volt reading on this throttle position sensor, and you know, it was fixed, it was not moving at all. Really what we would need to do is we would need to drive this signal high ourselves to confirm wiring integrity to the engine computer. To show you a little bit about what I'm talking about here, and to prove that this throttle position sensor is in fact sending this voltage to the engine computer, all I'm going to do while you guys stay focused on that is I'm going to unplug this connector. I've got the connector unplugged now, and as you can see, this number dropped to 0 volts. So we initially had that 0.57 volt range, and as soon as I unplugged this sensor, guys, we went to 0 volts. So if you had a vehicle that came in, and this is what you were seeing on the scan tool, especially on this vehicle being that it's a pull-up design circuit, you know, you would really need to be worried about wiring integrity. And I'm going to show you guys how to address that and confirm that it is good. So if we get focused back over here on the vehicle, in order to do this test, guys, what we're going to do and what we need to do is we basically just need to pump voltage into the signal wire, which is the one that we're currently back probed in. You know, and we were looking at this number on the scan tool. It's currently reporting 0 volts. Basically, we just need to push voltage into this wire. There's a couple ways we can do that. I've seen some guys use 5,000 ohm resistors, and they just jump this signal wire to the reference wire. That's one way to do it. You can also use a test light to do this. You know, take your test light, place it to battery positive, and you know, just pump that reference circuit into this throttle position sensor voltage. As far as jumping the reference to the signal, you know, you definitely want to use that resistor in place there in case there is a short to ground on this. If there were a short to ground on this signal wire, guys, what this engine computer would be seeing all the time is 0 volts, without a doubt. So that being said, I think I'm just going to use a test light for this, guys. And I know some guys will probably disagree with this, but you know, I've had no issues with doing this in the past. So what I'm going to do to execute this test is I'm going to take a test light, a simple incandescent test light. You can also use an LED for this test. I'm going to attach that test light to battery positive, and I'm then going to touch this test light on this pin, and we're going to see what the reaction is on the scan tool. So let me get that test light, and I'm going to get you guys focused on the scan tool, and we'll do that. Alrighty guys, so I've got my test light set up. It is currently connected to battery positive. I've got you guys focused on this voltage number on the scan tool. All I'm going to do is I'm just going to touch my test light on this T-pin, and we're going to see a voltage response from the scan tool, so I'm going to do that now. So as we can see, guys, this voltage number is now pegged at 5 volts. I'm going to take this test light back off. I'm going to touch it on again and take it back off. So what that does for us, guys, is 1, it confirms that there's no short to ground on this circuit, and 2, it confirms that wiring integrity to the engine computer is good. You can see that our maximum number we achieved with that is only 5 volts, even though in reality we were really pumping battery voltage in through our test light. That is simply a substituted value by the engine computer, guys. The engine computer is not going to report battery voltage because it does not expect to see battery voltage on the circuit at any time. So, but that's a very quick, down and dirty test. Just to confirm wiring integrity is good on a pull-up circuit design. I think we talked a little bit about this when we were dealing with the cam sensor issue on that PT Cruiser. But just to show you that test again, and just to show you what I was doing, I've just got my test light hooked to battery positive. You can see when we find the ground, it's going to light. And I'm simply taking this test light and I'm just touching this T-pin on and off. I'll do it pretty rapidly here, just for the fun of it. And that's all we're doing, guys. Get you guys focused back on the scan tool, and you can see the response that we just generated. So without a doubt, guys, wiring integrity is good, but this is a super good way to confirm wiring integrity on a pull-up sensor design like this. So yeah, that's pretty much it, guys. So let's wrap this one up. So yeah, guys, we absolutely flew through that one. P0122 throttle position sensor circuit low voltage here on this 2001 GMC Sonoma. We very quickly attacked this. We had to do some minor tear down to get to it, no big deal. Some highlights of this, this is a 3-wire potentiometer, pretty standard for throttle position sensors of this vintage. Troubleshooting this, very simple. It's a 3-wire potentiometer. We have a 5-volt reference, a sensor ground, and a signal wire. We identified that this signal wire is a pull-up design, so this sensor is actually sending voltage to the engine computer, not the other way around. So we got to be a little bit creative when we're thinking about doing wiring integrity tests on this design circuit. It's not as easy as just unplugging it and verifying that we have 5 volts there. But we went through a couple different methods of testing that and verifying wiring integrity to the engine computer was good. We touched on doing throttle position sensor sweep tests to catch dropouts and glitches. This one we clearly had a very clear dropout just kind of right off the initial opening of the throttle plate, so it was pretty easy to pick out on the scan tool as well as on the scope. But yeah, this one was pretty easy, guys, and we covered it pretty fast, but not a whole lot to them. But anyways, we still have this secondary air injection system fault code to worry about, and I would say that would be a part 2, but it's really just going to be a separate video, completely different system, unrelated to this throttle position sensor fault code that we had here. So anyways, that's it for this one, guys. I really appreciate you guys watching, and super happy about having so many loyal fans that stop by my channel every day to learn together. So anyways, guys, any concerns or any questions or anything like that, just leave them down in the comments, and I'll get back to you. I read all of you guys' comments. And as for this throttle position sensor issue, that's it, guys. We're all done. Thanks for watching.